continue with the simulation now that we are done. So you can look at this. As you can see, even around 120, our solution has stabilized, and you can see it here. So it does not really matter. There is a way to confirm when your simulation has converged. So you come to results tab here, then click on fluxes. So click on all the inlets and the outlets, then compute. So long as the difference is a lot, so we can see our result is it has converged. So let's just do for these two, so we see it here, then do for the odds. So as you can see, the simulation has converged, or the simulation can be correct. Yeah, so we have the graphical part, we have the plot, that's graphs, and then we have the report part. So one thing we would like to confirm is the outlet temperature. We want to know the actual value, so come to the area weighted average, come to temperature here, static temperature. So you can just click on everything here and here, so that we will know all the temperatures, so we can see them in the what they call it here, in the simulation console here. So the code inlet was 20, and then the outlet was 24. Yeah, so it means that the temperature rose from the inlet to the outlet, and then for the hot inlet it dropped to 31. So it shows that the heat exchanger actually worked. So we have that, and then we can get, I think, no, if yes, we can get the efficiency. So the efficiency is just we are looking at the inlet and the outlet, so we'll check the this thing, and then we'll confirm it. Uh, how did you do it? It's static to static. Yeah, I'm not sure of how to do that. Okay, so we are supposed to get the efficiency of the heat exchanger, but even you can use the logarithmic temperature difference to get the efficiency of the heat exchanger. So that's also a method. I don't know why I didn't get the efficiency from this one. That's also something I can consider. So for the flux report, you can get the mass flow rate, you can get the total heat transfer rate. So that's in watts. So we want to see the total heat transfer in the whole setup of the simulation. You can set everything up, so you can see everything, all the heat transfer rate. Yeah, so we move to the graphical part. For graphical part, you can set up some maybe line, so line that would go from maybe this point to that point. So we'll see the temperature change along that line. So that's something that we can consider, and other things here that we can consider for the plots and everything. But I focus more on the graphics, because they will actually appreciate what we are doing. So the first thing we would like to create is the contour. So go there and create the temperature. Okay, let's create a plane first at the center. So right click on surfaces, so new, then plane. So a plane that will cut through it. Yeah, so create this plane, then come to contour, then change this to temperature. I want to see the temperature in that plane. So as you can see now, our heat exchanger here hot, it became cooler here, then this acted upon it, and it also increased its own temperature, so you can see everything. So this is just a basic heat exchanger. So let's just see everything. Let me move the plane, and so as you can see it, and see the temperature change. yeah, so can see the temperature change. So that was why I created the plane from the I created plane so we can see the temperature difference at the middle. So that's also important to note. Yeah. Mm, oh, this was even the pressure. So change it to temperature. Okay. Yeah. So we appreciate it better. I will say that. So another important one is the vector. So vector, yeah, you'll be able to confirm the flow direction. So um some simulation might not be correct. Some might have like unnecessary backflows and everything. So you just want to confirm that, oh, my velocity and the temperature, I mean the fluid are moving in the right direction and whatnot. So don't mind this. Can add skip, let's say 2. Let's see. Ah, I think that's the outlet for it. Let me just move for the outlet. Still the same, but at least we get the idea. So let's color it by temperature. So you can see the hot fluid, it became cold, and then you can see this and the hot fluid coming from the body of this. So here in the path line, you can perfectly visualize the temperature movement and everything. So you can here just say color by temperature, check everything, and there's no need to draw the mesh, just save and display. Should have put some path skip here because it might take a bit of time for it loads. Okay, so that took a bit of time. So let's change the path skip to say 25. So let's save and display. Hopefully this doesn't take too much time. So once it displays, I would bring back the video. So we have this, then you can just click on the pulse. So this pulse will give it the fluid. You see how the fluid is moving. As you can see now, how the hot temperature is moving out and the cold temperature is moving there. So thank you for watching. So you can see the hot temperature moving out and the cold coming out. So yeah, so to save it, I just close this, then Okay. So once this closes completely, so you can come to this, then either you come here, save it, or just press Ctrl S, either of the two. So you come here, then it's also important to save it to a location that you can easily access, say maybe the desktop, then right click and create a new folder so that both the file and everything would be inside. Let's say it's exchanger. So you come in inside the dex inside the folder, then save your he, because it will save two files that are actually important to the design. So you save. So once it's done saving, so you can always come go back to the desktop. We have our he here, and then you can always, because this backup is showing because the file is still open. Once you close it, the backup will go as if we have not saved it. Then so you can always access it with this file. So this is the folder that contains the results. So these two folders are very important whenever you are submitting your work. So thank you very much for watching.